Morning everyone, Dr. Eric here, your fitness physician here with Primex Cellular Fitness. I'm going to do a short video, actually a little bit of a longer video today. I'm going to be talking about hormones and exercise and how they correlate and how they can help one another and the benefits of hormones on exercise and vice versa. So I think it's there's a lot to be discussed in this regard, but obviously we talk about the importance of nutrition, hormones, and exercise and how they all play together to make the body function optimally. So exercise, of course, we all know there's low intensity, moderate intensity, high intensity, and resistance training. There's HIIT, there's lists, all these different acronyms. So we'll talk a little bit about those and how they play into hormones. Hormones, of course, are molecules in the body that are ubiquitous. They're everywhere. They control numerous metabolic and cellular functions, whether it's energy, metabolism, reproduction, tissue growth, tissue repair. They affect our mood, our emotions, our appetite, how we eat, and it plays into food. We're going to have another video in the future talking about hormones and food, as well as how it controls appetite and obesity and weight loss. Today we're going to focus specifically on exercise. So hormones are, again, they're absolutely necessary throughout the body. They're involved in millions of processes. There's multiple different kinds. In general, there's three basic types. There's more than that, but there's steroid hormones, there's peptides and amines. Amines are basically have an amino acid component attached to them. They're involved more in neurotransmitters. Peptides are shorter protein subunits. They tend to interact at the more at the membrane level, or I'm sorry, in structures, different structures inside the cell, whereas steroid molecules tend to have receptor sites on the surface of the cell membrane and interact that way, although there are exceptions, and there is some crossover, but they crosstalk and communicate, and they're involved in stability, structure, and communication amongst the cells. Think of hormones as little messengers and signaling agents. Peptides especially are known to be signaling agents. Steroid hormones as well, but also, again, you hear about that lock and key mechanism. They attach to a receptor and turn that receptor function on and turn that cellular process on. So they affect this through different ways. So basically, steroid molecules, teptides, and amines are the three basic types. And in general, again, they have many functions. A lot of people think of hormones as anabolic or catabolic. It's a good, simple way to think about it, although, of course, it's more nuanced and detailed than that. Anabolic, of course, is about building the body up, making it stronger and better, repairing tissues, muscle growth, things of this nature, whereas catabolic tends to be breaking things down, which can be a good thing in certain situations in terms of breaking down food and breaking down other substances, toxins. Obviously, we don't want catabolism in terms of breaking down our muscles, or cell structures and things of that nature. So there's differentiation there. So muscles are massively important for the body. We think of muscles as the largest endocrine organ in the body. Actually, we're finding out more and more about all that muscle can do and all the cytokines, myokines, and other mediators that it produces. That it has numerous effects on the body. It has effects on insulin, amino acids, fatty acids. It can affect the oxidation of fatty acids, oxidation of glucose. And fortunately, by increasing our muscle and having adequate muscle and muscle function, we massively improve insulin sensitivity, which we all know insulin resistance is rampant in our society today. So we want to curb that down. Myokines are little molecules that are made by the muscles, which have numerous cellular functions, and we're finding out more of these every day. It's pretty fascinating. I did kind of like a keynote presentation with some images, which I can't see, which obviously you guys can't see, but I'll share this as well. There's a cool image kind of showing an infographic of muscle and all that it can do. It's pretty cool. One of the myokines and cytokines it produces are IL-6 or interleukin 6, which can affect increased glucose intake. It increases the AMPK, which of course has many benefits, as we've talked about, which can lead to increased fat oxidation, increased fibroblast growth factor, IGF-1 and FGF2. IL-6 and can also, combined with Irisin, which I'll talk about later, increases lipolysis and fat burning, increases the UCP, or the uncoupling protein, which helps with thermogenesis, again, with help with fat oxidation and fat burning. One of the other things in terms of the other myokines that the muscle can produce, it basically can help with follistatin, which inhibits another molecule called myostatin. Myostatin actually prevents muscle growth, so this is a good thing. We want more follistatin to that way we can build muscle, have hypertrophy. IL-6 and some of the other cytokines also can benefit hepatic function, hepatic glucose production, especially during exercise. Follistatin-related protein 1, which is another one that's produced, can help with promoting endothelial function, which of course is massively important for our blood vessels. IL-6 can also, as I mentioned, can help with GLP-1 and other substances to help with increased insulin secretion and better insulin sensitivity. And lastly, IGF-1 and FGF2, as I talked about, can help with bone. We need strong, healthy bones, especially when as it relates to exercise and longevity. So this is just a sampling of this, guys. This is starting to get a little geeky, but lots of little cytokines and myokines. So try to not get too geeky, but it's important to hear, and I want you guys to know that I understand. I'm trying to break it down on a simple level, also take a little bit further than what you probably hear about on the Instagram posts from the people who aren't delving into this. Like I said, I like to delve into it at the cellular level, and that's what we're going to talk about. So aerobic exercise obviously improves mitochondrial oxidative enzymes and improves insulin sensitivity. HIIT, or high intensity interval training, improves, of course, fitness, insulin sensitivity, mitochondrial respiration, and can improve your fat-free mass and increase fat burning as well. Resistance training also can improve, obviously, fat-free mass. Obviously, we want to get big by lifting weights, right? But it also massively increases insulin sensitivity. So it's good to have all three kinds mixed, and some people do better with certain proportions of each, but we'll talk about that a little bit more later. HIIT, in general, is also a little side note on HIIT. As I mentioned, increased lipid oxidation and fat oxidation. It can enhance peripheral vascular structure and function, and again, improved insulin sensitivity. As we talked about, muscle is the biggest endocrine organ in the body. So there's a reduced rate of lactate production in general, and glycogen utilization. Basically, we can burn more fat and build more muscle and recover faster with HIIT, and obviously it's more time efficient too. Again, I could put a cool little picture infographic on the other presentation talking about exercise and how it phosphorylates another molecule inside the cell called PGC1 alpha, which is then taken to the nucleus of the cell to activate mitochondrial gene transcription, a little molecule called TFAM, which increases mitochondrial biogenesis, which of course we all know are the powerhouses of the cell. The more mitochondria have, the more energy, the more power we have to do stuff. Okay, so one last note on HIIT is that we found that actually can have faster recovery because it balances out that parasympathetic and sympathetic tone, as opposed to just slamming it and doing long runs. We all know about endurance training. It's good in limited bursts, but people that are running for hours and hours, a day or multiple times a day, this can actually be more catabolic and crank up the sympathetic system too much, and there's less recovery. So shorter bursts and a lot of people tend to do better in terms of recovery, overall muscle function and repair. Another thing, especially when combined with fasting, which I'll talk about later, but a little secret of mine, guys, little pearl, is doing HIIT before your resistance training upregulates satellite cells, which leads to better repair, better recovery, better muscle growth and hypertrophy. So doing a short 4 to 5 minute burst of HIIT before your resistance training will massively help this. So I've done this myself and I love doing it. A lot of people say, oh no, you got to do resistance training first before endurance, and that's true if you want to focus on resistance. But again, a short burst is very different than going slamming it for 20 minutes hard on a high interval start. We're talking about going almost like a Tabata protocol, 4 to 5 minutes, rest for a few minutes, recover, and then go do your resistance training work. I've had no decrement in my training when I do that, and I actually do feel a lot better with faster recovery. So give that a try. Another little infographic I'll link to is talking about how combining HIIT with strength training, especially in older adults, and those people that we're all talking to here, those over 40 and 50, can massively help with in preventing age-related decline in muscle mitochondria, increases in the transcription of proteins involved in muscle growth and mitochondrial pathways, and it has a lot of reversal of many age-related changes in our mitochondria and our cell. So lower protein damage, better recovery, and again, better mitochondrial biogenesis, which of course helps us live longer. We all talk about how the mitochondria are involved with many age-related processes. Next, we're going to talk about hormonal exercise. We have all heard about that metabolic afterburn effect, right? The EPOC, excess post oxygen. I can't even talk today, but EPOC, we all know what that means. Sorry, a little brain fart today, guys. But it's related to the intensity of the exercise, increased metabolism, and we talk about you'll know if you're in that zone. It's that anaerobic zone, right? You're going to be hot. You're burning. That's from the lactate. It's actually from the hydrogen acid ion attached to the lactate. You're going to be hot. You're going to be sweaty. You're involving those heavy muscle fibers, which are the type 2 fibers. So you're lifting heavy weights, and you're breathless. You can't carry on a conversation. So a friend of mine, JT, just says, breathless, burning, heat, and heavy, and that's a great way to put it. Combines all those things together. It's that anaerobic zone. We found that it's not, basically it said this increased EPOC and increased metabolic afterburn helps you burn calories after the workout's over, and that's the advantage of HIIT and strength training. We found it's not as big of an effect as we found after all, but it still helps. Every little bit counts, and again, it's more of that efficiency factor. So I'll put another picture on the video. We've all seen the pictures comparing the sprinter versus the marathon runner. Who do you want to look like, guys? I know I want to look like the sprinter. You know, they're jacked, they're muscular, they're lean, they're fit. I don't want to look like a victim from a camp, right? And you're all kind of shriveled. So that's just not healthy. Okay, that's it for this video, guys, and we're going to talk about some specific hormones in the next one. Next one we're going to talk about is, hey guys, Dr. Eric here, your fitness physician here with part 2 of hormones and exercise. I'm going to talk a little bit basically about some of the specific hormones. I'm not going to get too deep into them because I'm going to talk about them in future videos. But the first one we're going to talk about is insulin. Everybody knows about insulin. It regulates carbohydrate and fat metabolism, glucose level regulation, fat storage and breakdown. When we want insulin level to be high at certain times, for example, post-workout, because it's an anabolic hormone and more of an anti-catabolic hormone, but we want to increase the flow of amino acids and glucose into the cell to boost muscle hypertrophy. However, we don't want it raised all the time because it's involved with glucose metabolism, but therefore you can't burn fat when it's elevated. So when it's elevated all the time, of course, we're more into carbohydrate mode, right? So when we want insulin levels low, when we're not working out or the rest of the day or as much as possible, because then we're enabling our body to burn fat instead of sugar. And it also decreases inflammation and has many other effects on the body, which we'll talk about later. But we've all heard about insulin resistance because insulin levels are too high because we're eating the wrong foods at the wrong times. And that's one of the keys we'll talk about later, eating the right foods at the right times to optimize that hormonal milieu in your body to crank up fat burning and muscle building, and not the other way around. That way we can do the things we want to do without having to really restrict ourselves. So by manipulating that insulin level and how we eat, and then in the timing of it, we can have the appropriate anabolism when we want it and the appropriate catabolism breakdown of fat and fat burning when we want it. So glucagon is the opposite. It stimulates release of free fatty acids to increase glucose levels, mostly from the liver. It breaks down the glycogen, increases a process called gluconeogenesis, and it can definitely help with the fat burning effect. So optimizing your amino acid intake and exercise program will actually help boost glucagon again at the right times. We all know about the cortisol. It's involved in the breakdown of triglycerides, fats, proteins. It's catabolic in general. However, can it be very beneficial? Again, it all comes down to timing, right? Acute versus chronic elevations. We want cortisol to be high in the morning. We want it to be high when we're ready to exercise. That's why we have that circadian rhythm. Where in the morning, our cortisol is up because our bodies are trying to wake up. That's a good time to exercise. Our metabolism is cranked up. Cortisol is going to help with that fat burning. Again, if you're fueled and rested properly, that's what you want. You're going to burn the calories, burn the fat. You're going to break down some of those fat tissues. That's what you want. However, it should come down. After your workout, the levels need to drop. You need to chill and relax, balance out that parasympathetic and sympathetic tone like we talked about. People that are chronically stressed, chronically elevated cortisol, that's not good. That's the people that are gaining fat in the midsection. They're tired. They can't think. Obviously, this can be from other things too, but in general, chronic cortisol elevations are not good. That's what we want to avoid with proper lifestyle, timing, proper nutrition, and exercise and hormone manipulation. Epinephrine and norepinephrine are involved in the sympathetic nervous system for energy production and neurotransmitters, also involved in the breakdown of glycogen for energy, glucose production, fat metabolism, increasing cardiac output, and again, they're involved in neurotransmitter functions as well. Again, this leads into what we talked about before, timing. We don't want to have them be chronically elevated because that's not good, but getting them cranked up at the right time is exactly what we want. Thyroid, of course, is involved in numerous processes: metabolism, fat burning, overall every process in the body, and that can be affected by many things, including nutrition, exercise, stress, sleep, and hormones. Sometimes we need to supplement with thyroid medication. A lot of times we could correct that with proper addressing adrenal function, addressing sleep, addressing stress, and many other factors. Leptin, GIP, and GLP are hormones and definitely involved in metabolism and definitely involved with weight and body composition. We'll delve into more of that in future videos because I could talk for hours about this, and there's a lot out there on the blogosphere, of course, talk about that. But leptin is the satiety hormone. It tells your body when you're full, and when you've eaten, it's supposed to turn that off so you stop eating. A lot of people become leptin resistant along with insulin resistance, and that just doesn't work, and they just keep eating, and that's why they gain weight. It affects your body's homeostatic set point, and so the key is to decrease that leptin or increase leptin sensitivity, similar to increasing the insulin sensitivity, and that comes down to, again, proper diet, proper foods, eating the right foods at the right time, and we can also put in some intermittent fasting to help with that as well. GIP and GLP are also involved with this, and again, we'll talk about that later, but they're massively important as well in promoting proper metabolism, sensing in the brain, glucose disposal, and things of this nature. Of course, testosterone is an anabolic hormone involved in muscle growth, fat burning, and numerous other health functions, which I've talked about in other videos. Estrogen and progesterone are also very important in terms of proper metabolisms of fats and amino acids. And again, numerous health benefits of all these hormones, getting them optimized perfectly. And a lot of people, unfortunately, as we get, my target audience, right, guys and women that are over 40 and 50 tend to have a disturbed metabolism. These hormones get out of whack, so we need to correct that. The next one is human growth hormone and its counterpart, IGF-1, involved in muscle and growth repair, the immune system, neurologic function, fat metabolism, fat burning, lipolysis, as well as tissue repair, muscle growth, and system repair in general. Both of these are great to have elevated at the right times. Again, we produce most growth hormone at night, and to get these normal pulses, the levels that rise and fall throughout the night. We do get some pulses during the day, but most of them occur during the night. Human growth hormone, which was given as a supplement for many years and still is okay when it's used properly, but the problems is it's a little bit limited in scope, can have some side effects and lead to inappropriate elevations of the substance, whereas by optimizing it naturally through natural production or even through the use of peptides, making our own body increase its own production, it is important to have that balance. Again, it's all about the balance. We don't want these processes cranked up all the time. We want times of breakdown and healing and times of growth. That's why we talk about the balance of mTOR and AMPK, of growth hormone and lower growth hormone. So that's why our body cycles through these processes. These are massively involved and can be affected by nutrition and exercise. Brain-derived neurotropic factor, BDNF, is also improved or increased during fasting and during exercise. Massively important with neurogenesis, improved cognitive function, and again, it's boosted by those same factors that increase IGF-1 and human growth hormone. Irisin is one of those myokines I alluded to earlier. It's involved with muscle hypertrophy and fat browning, basically converting white fat into brown fat. White fat's the bad fat. It's the fat that sits there and just grows and produces a lot of inflammatory cytokines, which can have many detrimental effects on the body. Brown fat, which we lose as we age, unfortunately, is involved with thermogenesis and fat burning and produces anti-inflammatory cytokines. So irisin can help with this, increasing the brown fat, decreasing the white fat. Irisin is also involved in stem cell regulation. Can facilitate the conversion into bone building and muscle building. It's also neuroprotective, and it's boosted again not only by exercise but intermittent fasting, high intensity interval training as well. So irisin is kind of a cool little molecule, cytokine or myokine, that's produced by the muscle. Kind of off topic a little bit, and not really off topic, but related to this, is talking about how growth hormone and its downstream effects can promote an increase in mitochondrial oxidative capacity and mitochondrial proteins. Again, it affects PGC1 alpha and TFAM, which I talked about earlier. PGC1 alpha is a key regulator of muscle mitochondrial biogenesis, and other proteins involved that can affect muscle phenotype, which is the type of muscle, type 1 fibers, type 2 fibers, etc. It also affects TFAM, as I talked about, which helps the mitochondrial biogenesis, and GLUT4 receptors, which are the receptors that shuttle glucose into the muscle during exercise. So that's why all these things fit together. When you have an energy need, these proteins get turned on. PGC1 alpha, TFAM, GLUT4, all these muscles get optimized when you have proper nutrition, proper fuel, and oftentimes we may need some support, whether it's hormones or peptides, to optimize these cellular processes. When your body needs energy to exercise, it needs to shuttle that glucose into the cell, so we need to upregulate those GLUT4 receptors, and needs to upregulate these mitochondrial enzymes and proteins to make the cell churn out ATP to give you energy to work out. So it's a beautiful system. When your body needs it, it turns on the right processes to make them happy. So exercise also causes what we call a phosphorylation, or adding a phosphate group. So it increases AMPK. Again, it goes back to that energy sensor function, which is what it is. AMPK is an energy sensor. When your body is ready to work out, it cranks up these processes, increases GLUT4 and PGC1 alpha to increase AMPK to provide you that energy. Fasting, interestingly, also increases AMPK, but through a different mechanism. I'll touch on that a little bit later, but there's a little metabolic switch. It converts the body to burning fatty acids for fuel, which again leads to an enhanced expression of genes involved in fat oxidation, and again, by mitochondrial biogenesis. There's also an increased expression of UPC3, which helps to, as I mentioned earlier, talking about increasing thermogenesis and releasing of energy as heat to help not improve the heat and get rid of that heat, but to help burn fat as well. We can get really geeky and get in and talk about like increased PDK4, which inactivates a molecule called pyruvate dehydrogenase, which decreases carbohydrate oxidation and shifts the body more into fat burning mode. And this can be helped again with fasting, HIIT, things of this nature. It also increases, as I mentioned, PGC1 alpha, but another molecule called PPAR gamma, which also increases oxidative metabolism. So these are all the more the deep level kind of molecules that are increased by appropriate nutrition and exercise. Interestingly, fasting with exercise can lead to muscle adaptations that improve performance. So increased oxidative capacity, increased lipid breakdown, fat burning. As I talked about earlier, exercise increases AMPK, but fasting does it as well, but through a different mechanism. It basically dephosphorylates another molecule called eukaryotic elongation factor 2, which leads to the initiation of muscle protein translation and repair. So bottom line is they both increase AMPK, but through different mechanisms. That's why it's important to do both. And when you combine fasting with exercise, you get the best of both worlds. That's why I mentioned it earlier. When you combine fasting, a lot of people don't like to exercise in a fasted state, and maybe you can't do it, but if you can adapt to it, try it out a few times. As I mentioned, be fasted and then do it in an interval session, or if you're going to do a weight training session, what I do is do some amino acids, essential amino acid cocktail before your workout. That'll help with muscle breakdown and muscle growth, and do your HIIT training, do your resistance training, and then you get the best of both worlds. So as I mentioned, fasting before exercise, it turns out it basically leads to better repair and more muscle growth because it turns on mTOR faster. mTOR is when you're fasted, AMPK is high, mTOR is low. But when you're muscle building, you want the opposite, right? So by doing this, you're priming your body to turn that mTOR on faster. So that's a little secret. So if you're doing these things first, as soon as you're done, when you're doing the weight training, the mTOR is going to turn on faster than what it would if you hadn't done that otherwise. So you start that muscle building process faster. So that's the secret sauce. So anyway, I just want to let you know that I'll put another cool little infographic on there as well. So one other thing about fasting before exercise is that you get an increase in lactate output. Lactate, as we're finding, is actually not a bad thing. A lot of people think of it's bad because of the burn and the muscles, but again, that's from hydrogen ion. But lactate is actually a fuel. It can be used in the liver in a little process called the Cori cycle to help with gluconeogenesis or glucose production. But fasting before exercise, increasing lactate, not only can lactate be used as a fuel to provide energy, but it helps with myoblast differentiation and satellite cell activation. Basically, the myoblasts are the kind of premature muscle cells, and satellite cells are the little stem cells that can turn into other tissues like muscle. So by enhancing this, you're going to have increased regeneration of injured cells, better tissue repair. So you're turning these satellite cells and the myoblasts into functional muscle cells and functional tendons and other things of this nature. So bottom line is promoting repair and tissue. One of the other kind of molecules that's involved with this is MGF, which is an isoform or a subunit or kind of a subform of IGF-1, which is it's basically produced by mechanical stress and again leads to increased tissue healing and repair. MGF-1 can be actually used as a peptide, but when we use the GHRPs and the growth hormone releasing hormones and growth hormone releasing peptides, it can help increase MGF as well and help to promote all these processes on a natural level, which we'll talk about. And one last thing about fasting and exercise, as we talked about earlier, is that you increase adrenaline and epinephrine, which increases your metabolic rate. And again, you're timing your circadian rhythm when your cortisol is high, which can increase with fat burning and insulin sensitivity. We'll talk later about peptide therapies and peptide optimization as well, and how to do that. Okay. One last video, quickly I'm going to talk about the dangers of overtraining, because as we're talking about hormones and exercise, we have to be careful with that. Obviously, moderate exercise can improve the mood, increase fat burning, increase muscle growth, reduce stress hormones, etc. But too much exercise, too hard, too long, too much, increases cortisol too much, and it stays elevated, as we talked about earlier. Increased abnormal response with blood sugar. You can actually have too much catabolism, burn off amino acids. You have increased mineral deficits because you're burning off you're metabolizing your bone. You can have a catabolic metabolism, again because of too much stress hormones, too much cortisol, increased propensity to get injured, decreased metabolic efficiency, and more. So that's where moderate, regulated exercise as opposed to overtraining, intense, too much exercise, too much. People hitting CrossFit or Orange Theory, etc. every single day. You got to back off and balance it out with recovery. Overtraining can lead to neuroendocrine immune imbalance, increases in inflammatory cytokines like TNF-alpha and IL-1. It affects anabolic hormones. Your thyroid, your testosterone, growth hormones can totally throw that off and derail that because, again, too much cortisol, we're throwing that balance off. You can have sleep disturbances, mood disturbances. People just don't want to work out. They're fatigued, they're tired, they're cranky. So again, we want to improve this moderate, appropriately timed exercise. One interesting study, they talked about testosterone deficiency in aging athletes, and they combined, they measured the testosterone levels and looked at that balance versus the cortisol level, and they divided them into 3 groups: endurance training, resistance training, and concurrent training where they did both. It was a 12-week protocol. What we found is that over time, especially the endurance, they tend to have a drop. More cortisol, less testosterone. That ratio is skewed abnormally, whereas one or the other was much better, especially when they're not overtraining. So I'll put an infographic on the webinar about that. But the bottom line is you want that balance of cortisol and testosterone. You want to avoid overtraining, and you'll know when you're more sore all the time, you decrease drive to go to the gym, and you just don't want to do it anymore. You're not recovering, you're sick all the time, etc.